Capstone project explores cultural reaction to climate change during the Holocene. Before we get into analytics of climate change and culture change, let me go over some key background information. The geologic timescale is a chronological dating system used to describe events on Earth. The geologic timescale is widely accepted and used in a variety of disciplines, including geology, paleontology, and anthropology. The geologic timescale is divided into several divisions of time, including supereons, eons, eras, periods, epochs, and ages. This image represents the geologic timescale as a clock, citing critical events in Earth's history. The Holocene epoch falls into the Quaternary period of the Cenozoic era. The Holocene epoch represents the last 11,700 years of Earth's history on the geologic timescale. The Holocene epoch can be split into three distinct periods based on cooling and heating trends analyzed in various research projects around the world. The first period is commonly referred to as the Holocene climate optimum, which was between 9,500 and 6,500 calendar years before the present. Next is the Holocene transition period, which represents 6,500 to 3,000 calendar years before the present. The last period is the cool late Holocene period. The cool late Holocene period represents 3,000 years before present to now. We are currently in the Holocene epoch. During the last 9,500 years, cultures across the world have been affected by climate change. Human populations that have been greatly affected by climate change over the last 9,000 years include Sakak and Dorset populations in Greenland and Quebrada Puerpica in Chile. Based on analysis of geological and anthropological data, I have concluded that rapid warming and cooling trends of ocean and terrestrial land brought unanticipated hardships to human populations across the world, forcing once prosperous populations to disband. As interdisciplinary studies require evaluation and synthesis of multiple disciplines, I have chosen to use geology and anthropology as my principal disciplines. Geologic analysis was helpful in determining overall temperature trends, while anthropological analysis was helpful in determining cultural response to climate change. Geologic analysis of collected sediment cores and diatom assemblages can be used to reconstruct past sea surface temperatures. Sediment cores collected in Greenland and Iceland were used to determine past sea surface temperatures. Atom assemblages, or reconstruction of microalgae, were also used in determining temperature trends during the Holocene. This chronostratigraphy of the Puerpica site in Chile shows a variety of sediment deposits and their relative age. The archaeological record can be used to determine that settlers in this region thrived in wetlands. My findings indicate that climate change in the Holocene can be generalized by early warming trends leading into gradual cooling periods. Reconstruction of past sea surface temperatures determined distinct temperature changes between the three Holocene periods. Compared to temperatures before the Holocene epoch, the Holocene climate optimum portrays a general warming period. Temperatures in the Holocene transition period indicate a cooling trend, with an average drop of 2.6 degrees Celsius from the temperatures before the Holocene. The cool late Holocene period indicates a more even distribution of temperature changes. Just as climate changed in the Holocene, culture changed as well. settlers across the world relied on the environment to provide necessary resources such as fertile land and fresh water. Drastic climate changes caused much relied on monsoon seasons to vary, freshwater lakes to dissolve, and droughts to occur. In West Greenland, Sakak settlers were forced to diversify their resources to combat the cooling trend. They became more reliant on ocean life for food and nearby settlements for trade. Unfortunately, the Sakak settlers were forced to disband because they could not keep up with the demands of their environment. The cooling trends became too extreme for the Sakaks. Soon after, Dorset populations occupied West Greenland. The Dorset were well adapted with the cool weather and were then able to survive a warming period. The Dorset eventually disbanded, but it is undetermined if climate change was a factor. As the Holocene epoch is representative of modern time, I would suggest a comprehensive reconstruction of all Holocene sea surface temperatures once the Holocene epoch is over. A complete reconstruction of sea surface temperatures can then be used to determine actual cooling and warming trends over the entire epoch. Full analysis of terrestrial sediment deposit and the archaeological record would help in defining actual cultural and climate trends. Perhaps the three previous identified Holocene periods will be reevaluated with complete data. In conclusion, periods of rapid warming and cooling in ocean and terrestrial lands prompted cultural responses from settlers across the world. Under drastic warming and cooling conditions in the Holocene, once thriving populations were forced to disband.